Sivaram, and we can begin.
Shall we start? Think, okay. Hello, everyone. Welcome to the session of Wokwi and the live demonstration of Robosoccer 25 of a part of Margali 25. So yesterday we have a session over TinkerCad simulation part and an intro to our event. So yesterday we have covered the basics of TinkerCad simulation, and whoever who doesn't watch can't attend the meet yesterday. Please make sure to check out the recording available in the YouTube. You can find that there. And speaking about yesterday's session, it was covering all the basics that needs to do with the simulation in a TinkerCAD. Yesterday, our team member Stevens covered the part, and he teach all of the participants about the simulation in TinkerCAD with two types of robot. One is a obstacle avoidance robot, and another one is like the same but with the IR controller, which means like a remote, using a remote, one with a remote and another without a remote itself. And today we have Likit, who is our team member, who will demonstrate you about the simulation in Wokwi, which is another tool that we will cover in this event today. And yeah, so guys, if you have any doubts regarding the yesterday's session and of course in today's session, please either reach out to the group members directly, so you can get your queries resolved there. And don't worry about that things that you can't understand. Please directly put the uh, message in the group itself. We will resolve your queries there. And today we will have to have a live demonstration also. So yeah, who are in the meet, stay in the meet until its end, because we have a live demonstration of a robot in this meet. Live means it's a physical one, it's a physical build, and it will be demonstrated by our team member lately in that meet itself. After Likith completing his session on Wokwi, we will have that also. So stay tuned until the meet ends. And so guys, if you have any queries about the last session, I mean yesterday's session on Tinkercad, if yes, uh, you can ask. If not, yeah, go ahead. Who is that? Yeah, someone raised the hand. Manish.
Yeah, I have doubt in the coding part of the IR car of the remote.
Yeah, yeah. We understand that the yesterday's session is little bit hurried up in the last minutes. So yeah, we will cover that code part itself in the like in another video. You will get that video in the group. So post your queries regarding the code part in the Robosoccer group, official group, and we will solve that.
Okay.
Yeah, it is showing error in yesterday's code. Seeing it. So actually, it is the. I mean, who is that?
Raghav.
LMF. Yeah, Raghav. It's like a declaration error. You have to ensure that LMF is declared. I mean, before you use that in any part of the code. Just to go through the session again, and you will get that, because we want self learning also in that event. so that we are covering all the basics that you need to know about each component and the working. And you have the span of 3 days, so you will get a lot of self learning there. We also ensure that self learning needs to be covered in this event. Yeah, you will get that. I think it's enough. Likit has start the session. Yes, Likit.
Yeah, so there are only
Yeah,
30
okay.
people. So shall I start?
Uh, okay, Likit. Yeah, you can start the session.
Okay. So good evening, everybody. I'm Likit, and I'm from IIT Madras BS in ES program, and I'm currently pursuing my diploma. So today I'm gonna be taking a session on Wokwi. This is another simulation tool. Let me just share my screen. Yeah, I hope you are able to see the screen. So this is the simulation tool which we'll be using. So I'll request all of you to go to wokwi.com. That is WOKWI.com, and please log in or sign up. Uh, I'll give you 2 minutes for that, so we can go hand in hand.
Likit, we can continue.
Yeah. So this is the Wokwi simulator. Over here we can simulate Arduino Uno, Mega and Nano, ESP32s, STM32s, and Pi Pico. I'll be going for Pi Pico because that was what I had used to build my robot. So here we can see few examples that are featured by the Wokwi, which they have built. So you can take inspiration from these. It also teaches you a lot about other stuff. For example, let's see, these are the starter templates. So right now we'll be using the one with MicroPython. What we essentially needed was PyPico W MicroPython, but we right now only have MicroPython available for us. So we can go forward with that. I'll ask everybody to open this starter template. One disadvantage with Wokwi is that you won't get a inbuilt L298N or any other motor driver like you got it with uh, TinkerCAD. So if you search over here, motor driver, you'll only get stepper motors and stepper motor drivers. So instead, what I have done is I've gone ahead and I've created a Yeah. So I've gone ahead and created a JSON file which will mimic L298N motor driver. So you can see these two. Uh, this is the chip which is going to do the job of what we want from a motor driver. So I will share this code and the chip code, both of them, on the WhatsApp group later on. So let's see. This is let us start building this robot. This is basically a robot which will go forward and backward. Uh, and these LEDs we'll be using to determine whether the individual motor is moving forward or backward, because we don't have DC motors in Wokwi. So let us open a new file. Yeah. So here you can type in. Can you see this? Um, yeah. So we'll type in this L298n.chip.json, which will help this file recognize this, and we'll get a pictorial representation on our diagrams.
Yeah, Likit,
Yeah.
hello. Yeah, man. Please give the overview of what you are doing and you are doing. Like, what if we explain with a physical one? If we explain with a physical one, it is better they can understand. In that manner, explain these things.
Okay.
Uh, Not only about the simulation.
Okay. So basically, we will be
Yeah.
making we are making three robots today. One of it is a robot which will move in a square shape, which is a simple robot. Then the second one, which we are gonna make a obstacle avoidance like we made yesterday in TinkerCad. And the third one is a mechanism wheel robot. It is a basic mechanism wheel robot. We are not gonna be controlling it as such, but we can give instructions through the command line or from the uh, program directly itself. For controlling the mechanism wheel bot, we will require a Pico W, which will have a wireless module, whereas our Pico MicroPython, which we are using right now to simulate, doesn't have a Wi-Fi module. In If you guys want to simulate everything, you can use ESP32, which is available on Wokwi and has Wi-Fi. So you can use that. But I went for PyPico because this has MicroPython. You can even use the MicroPython on ESP32, but I am not that familiar with ESP32. So let me show you a video of how the mechanism wheels robot works. Yeah. So this is a demonstration of how the wheels are going to be moving. When we want the robot to move left horizontally, we are gonna make the front left and front left and rear left motors. Front left will move backwards and rear left will move forwards, and the front right will move forwards and rear left will move backwards. The reason for this is, let me share that also. Give me a second. Yeah. So this is how a mechanism wheel looks if any of you have not seen it. So you're going to be having multiple rotors on a single wheel in a 45-degree angle. So when we will actually move the wheel in a forward direction, it will want to, if you're moving it in a standalone way, it will want to move in a slanting 45-degree angle when you're pushing it forward, when you're not rotating the wheel. So when we combine all these forces, so this is the force chart. So we can see when the front right wheel moves forward, and the all when all four wheels will move forward, we can see that the diagonal movements are being cancelled. This is what will happen with each different type of rotation. For example, when we move only the front right and the rear left wheels, we will have the bot move in a front right diagonal way. Let me show that also to you guys. So So this is how it will move. If this is going forward, this is going forward, these two are stopped. All right. And similarly, if this is moving forward and this is moving forward, we will get a diagonal left front movement. This is moving backward and this is moving backward. We will get this one. And this one, the front left and rear right, we will get a downward movement. Okay. And now, if we are going to be moving the front, these two in forward motion and these two in backward motion, we will rotate at the same position in a clockwise direction. And if we interchange the movements, we will rotate in a anti-clockwise direction. So with mechanism wheels, it's all about playing with how the wheel rotates, in which direction. According to this diagram, uh, yeah. So according to this diagram, you can see the forces being cancelled out, right? This will happen in each motion that you can see. Let me show you the video for all the motions. Just observe whatever is happening over here. I'll just pause and show you. Just like when I told you, it will move down, it will move backwards, the front left and rear right. It will move in a backward diagonal direction. right? So now I'll share a link with you guys. You can use that to copy paste the L298 and for now within the meeting. Give me a second. Yeah. So I've shared the link in the chat section. And Bhavya, I'll explain what I'm doing right now. I just gave an overview of what we're going to be doing in the session till now. So please open this link. If I can have people, if I can have people unmuted, it will be much better.
Guys, if anyone has a doubt, you can directly unmute yourself and ask rather than typing it in the chat box. So even if someone is viewing the session on YouTube, you will also understand what doubts you are having.
Okay, Bhavya, it's not the issue then.
Nikit, if no one has doubt, we can move forward.
Yeah, yeah. So we will right now use this project which has an L298 breakout board so that all of you guys can also copy it right now. Uh, so what we want you to do is open a new Wokwi with MicroPython test and name it. Uh, you can
Someone
rename your. Yeah, tell me.
someone is bad. Please tell your doubt.
I couldn't attend yesterday's class. Could you please send a YouTube link, sir, on this message?
The YouTube link for both the sessions will be shared after this meeting.
Okay, sir.
Yeah,
Thank
you
you.
In
can
the
get the link after this session.
Okay, sir. Thank you.
okay. So let me go through the uh, steps once again. So from the Wokwi homepage, go to PyPico. Here, scroll down to starter templates, and we'll go to MicroPython here. All right. I hope all of you have done everything till here. So now we will go to save. Name your project first. So after coming till here, I want you to open the link that I had sent you. Copy the L298n.chip.json and the L298n.chip.c. So we are using both Java and C to simulate how an L298n actually works. So let me just do that. Click here, go to new file, and you type in the names. Then copy paste whatever we have the contents inside here. And just save the program once. Now what I need you to do is select this board and then copy paste the board. You should be able to see the board like this. If it does not come, if it shows in a different manner, for example, let me just open a new one and show you. If it is coming out like this, then you have not copy pasted it properly or something. I would ask you to repeat the steps which I just told you. I hope all of you can see the chip properly. So next what we are going to do is we will take out LEDs, make 2 copies of the L298N and rotate this. You can press R to rotate. Make 8 copies of this LED. You can make 4 with red color and 4 with green color. The red will be demonstrating reverse movement and the green will demonstrate forward movement of the motor. So you can click on the LED over here. So it will show you the different options of whatever colors you can choose. For right now, we will choose the 0 and 1. You can even use the number pads to change the colors. For example, 1, 2, 3. Make total 8 copies of each, 4 copies of each color. Total 8 LED copies, 1 for each motor. We'll be making a robot with 4 motors, so we are using 2 L298 and 3 code ports. After you're done till here, now we'll start wiring up the Pico. So we need 3 GPIO pins per motor from the Pico. So total we'll be using 12 GPIO pins from the Pico. And we have an enable A and enable B. And what these 2 pins actually do is they are actually used for something called PWM control. PWM control helps us to control the speed of the motor. And the way this is done is it will turn on the motor and turn it off in microseconds or milliseconds. So what you can see is a slow moving motor, but what actually is happening there is that the motor is moving, it is turning on and off very fast. So the duration that will be on and the duration that will be off will determine the speed. So we will use this enable A and enable B pins for each motor to be able to determine what is the speed of the motor running right now. So when you select the, also what you can do is type in Pico pinout. So this will give you a pinout diagram which you can use to connect everything. So this is Pico 2. We need Pico. Yeah. So this is the pinout of Pico. So we can use all the green pins for GPIOs. And you can pay special attention to GPIO 4 and 5. These will be used for the main SDA and SCL pins. If you're going to be using something like if you're going to be using an LCD display or an OLED display, you will be connecting it to these two GPIO pins, the SCL and SDA pins. You can use the other ones, but primarily these two will be used. V bus over here refers to the VCC output. When you're connecting the USB to the Pico, it will provide 5 volts output to V bus. And your 3V3 out, that is a 36th pin, will provide 3.3 volts output, and all the ground pins are shorted. So you can use any one of them, it's fine. So we can start connecting our L298Ns. So we can start with GPIO 0, put it to ENAB, GPIO 1 to IN4. Sorry, this is ground. GPIO 2 to IN3, GPIO 3 to IN2, and so on. In this, we won't be using any other sensors, so we can use the GPIO 4 and 5 for this purpose. Here we will connect the chip to 5 volts to our V bus that I just showed you. So we can power up our Pico and the ground to any ground. So you can edit your wires by selecting it like this. You can change the colors or delete it, and if you have done a wrong, if your wiring is wrong, then you will have to delete the wire, and then you have to select a new wire and connect it. We will not be using the 12 volts output and the ground though for our project right now. Out 1, out 2, out 3, out 4 refers to our out 1 will be forward for first motor, and out 2 will be reverse, and out 3 and out 4 is going to be for the second motor. So we can connect the outputs to the cathode of which is going to be shown as C of the LED, and we'll connect the other end to the anode to the ground of this. Also, if you're going to be taking it from a chip, then it will automatically color code your required wire. So let me just connect the other two also. Yeah. Are you guys done till here? Can I get some response? Okay. Now what we have done on this side, we will just mimic the same thing on the other side. We'll connect the VCC for this uh, second L298N board also. Now all we need to do is gonna be connecting this out pins to our cathodes. So the output 4 is gonna go to our red, basically our reverse movement, and the odd numbers are gonna go for our forward movement. We are shorting the anodes. Okay. So our hardware setup is over. Let me go for an overview of what I've done right now. Here is our L298N breakout board, which will be having 4 input pins, 6 input pins. 4 will be deciding the direction of the movement of the motor, 2 for each motor, and we will have 2 for speed control. For now, we won't be using speed control, uh, and we will run the motors at we we are not going to be completely we won't control the speed of the motor using an app or something, but we will be running the motors at 50% speed. but you cannot see the difference because we'll be using LEDs in this case. So now we'll start coding. Okay, instead of typing the code, I'll just show you the code so we can complete it faster. I'll explain to you while we are going through the code. All right. So first we will define all four of our motors so we can interchange them as and when necessary. So our 4 forward is gonna be the pin 4 over here. So we can change the pins based on what we have given. For example, in the new one which I have named as test, I have used 0 to 4, whereas the one which I have already done some time back, for that I have used GPIO 23, and PWM I have used 15 somewhere here. So these pins you just need to change based on what you have put for the connections. For example, over here for E and B we have connected to GPIO 0, and for E and A we have connected to GPIO 5. So what we will do in this case is, here for our motor left front, so it is gonna be, or here we will have for PWM we will have it as GPIO 0. So pin, we will make it 0 over here. All right, in the code which you are using. And then for the left rear we will make it as pin number 5, and motor forward is going to be the one which you've connected IN1, and motor rear, motor to backward is going to be sorry, yeah, for your motor 3, right now we are using breakout board 2, so this, for this the motor 3 will be having IN1 for forward, IN2 for backward. Motor 4 will be having IN3 for forward and IN4 for backward. All right, so this is going to be our definitions which we will call in later functions. So is everybody with me till now? And does anybody have any doubts? You can unmute yourself and speak if you have any doubts. Okay, I'll continue then. Here we are enabling duty cycles. So duty cycle is what we are using for PWM. Basically, there will be a, let me just, yeah. So our PWM is gonna go something like this. These are on cycles and off cycles of the motor driver, which will be turning on and off the motors. So here we can see 32,768, which is going to be half of the maximum speed which our motor driver can provide. So this will be useful when we are connecting it to a motor, but right now we won't be using it. So the next one, what we'll be doing, we'll define functions for movements. So for move forward, we want all 4 motors to move in forward direction. So we will do motor 1 underscore forward dot on. So what this does is, what we have defined over here, motor 1 forward. So it will make our pin 2 high. So when pin 2 gets high, our out 1 will also go high. So when our GPIO pin 2 gives high for our in 1, our out 1 will go high. Similarly, if we give backward dot on, what happens is our in 2 gets high and in 1 will go low. Then our out 2 will get high and out 1 goes low. So the motor starts moving in backward direction. Then we'll define time dot sleep. We are basically using time dot sleep to tell the microcontroller to not do anything for certain amount of time. So we have imported time, which has the sleep function within, so inbuilt. So then I have also defined the stop motors function down here. So we'll just turn off all the motors for not showing any error, what do you say, output when we don't want it to. So if we don't put stop motors, what happens is the motors will continuously keep moving even when we have completed what we intended to do. Similarly, for backwards, we will have all four motors backward on, and we will make forward off. And for turn left, here is when your connections will matter. So based on your connections, if you have given the numbering properly over here, then you won't have much work. You'll just need to do 1 4 on 1 2 3 4, and for turning left, you need to move your both the motors on the left backwards and both the motors on the right forwards. So our robot will turn left. And when it comes to turning right, okay, wait, one of this is going to be deleted. Yeah, so I just had another function over there. Uh, so over here for in case of this build which I have made, we will have our this is my front right motor is going to be my motor 1, and sorry, rear right will be my motor 4. So I've taken, this is my motor 1, this is my motor 2, this is my motor 3, this is my motor 4, and you can see this is 1, and if you could be expecting this to be 2, but what has happened is we have rotated the L298N breakout board, right? So our out 1 and 2 will come out from the downside, and out 3 and 4 comes out from the upside. So that is why it is like 1 2 and 3 and 4, right? So here what I'm doing is 1 and 4. So this is 1 and this is 4. This is moving forward. So the bot goes like this in this arc. You can imagine. Let me just draw that also for you. So when this and this goes forward, our robot moves in this direction. At the same time, these two will be going in the backward direction. So the robot will turn at the position where it is standing. It won't move in a forward direction. Yeah, Pratham, I shared the main py file also. Though this won't be of much use, but you can go through it if you want. You can use any one of the software. Which one is more comfortable for you, Manish? So next, after all the functions are over, we have defined stop motors when all of them will be turned off. So what we are doing in our specific functions, we are just turning on what we require and turning off what we don't require. And after our function is over, we'll just call stop motors to turn off everything, whatever is running. So let us run this program right now. So what will happen in this program is it is going to move forward for 3 seconds, then it will turn right. As we can see over here, this for loop will run 4 times. So it will move somewhat like, yeah. So this is our first turn, forward, turn, forward, turn, and forward. So it will make a square. All right. So let's run the program and I'll show you. So we can see all 4 are moving in forward direction over here. And now after 3 seconds, See, these two went backwards. See, these two are going in reverse, and then that was the second turn. Similarly, the third turn, and now is the fourth turn. After this, the square is completed. So this is the basic bot which you guys can make. I hope you guys are doing the programming with me. Uh, Shivaraman, shall I share the code in the chat section? Is that fine?
Yeah, it's fine
Okay.
because those who are in the live meet only will get the code. Others will have to figure it on their own.
Yeah, I've shared the code with you guys on the chat in the chat section. Okay, wait. It, all right. Can I share links? I mean to say, like, can I share a document or something here because it's not taking the whole thing.
Yeah, you can share the document also. We'll add that document in the Excel sheet so that everyone gets the document as well.
Okay. Just give me a second. I'll create a doc and send it.
Uh, Guys, we will share this code in the Excel sheet as well that we are going to share with you on WhatsApp as well as GSpace. So those who aren't in the live meet, don't worry. We'll be sharing these codes with you also. You can try different things using this code, and or you can generate or make yourself code. You are fine with anything because this code will be with everyone. So try to come up with something yourself. That-
Yeah. So I've sent the code in multiple parts. You can copy paste it and make sure there is nothing overlapping or something extra. All right. So this is the main basic bot which we can make. If you guys aren't able to type it right now, we can just copy paste what I've sent and try it out. So let me show you the other bots that I've made and I'll explain to you what it is. So next one was just a simple forward backward movement robot. So what we can do, we can change our whatever we are giving over here output, right? So we are calling a move forward and a move backward function instead of move forward and turn right or turn left. So if you just change that, you can make the way in which the robot moves can be changed by changing these two lines. You can add other, you can call functions once again or you can call other functions to make more complex movements. So next, this is our obstacle avoidance bot which I have made. So what I've done here is I've just gone to add a new part. So you can search for all the parts that you require here. Though the library is not that huge, for your simple bots and other hobby stuff, this is more than enough. If you guys can't figure out something, like if you need something like L298N and you're not able to find it here, a simple hack which you can use is just go on Google and type working with whatever you need on Wokwi. You can find other people's code, whoever have made something like this, what I had shared with you guys. So you can simulate the working of chips that you're not able to find, but you cannot simulate sensors. Basic sensors are provided here. So let me tell you what this code actually does. This code will move forward until it detects an obstacle. So when the reading of the ultrasonic sensor goes below 15 centimeters, it detects the obstacle and it tells the robot to move in a clockwise direction until the distance increases more than 15. So we can use this to solve mazes and etc. You might have seen maze solving robots. They use something called a flood fill algorithm that is very advanced. So this is a much more basic version of the same thing. We can also attach 3 of these ultrasonic sensors in all 3 directions, and we can ask the microcontroller to check which is having the highest distance between the 3, and based on which one results the highest, we can ask it to turn in that particular direction. That will be faster than this. So let's run the code. Over here you can see the terminal. It is showing us what is the actual distance right now. We are setting it over here. So you can see all the 4 motors are moving in forward direction right now. So when I go below 15, you can see the right two motors are moving in the reverse direction. So the bot will take a right turn, or it will turn in the clockwise direction, to be more precise. So this will occur until the distance increases more than 15 or more than 15. So as soon as I increase it to more than 15, you can see it starts moving forward once again. So what this does is, uh, are you guys able to see my screen?
No, currently it's all white out.
Okay, give me a sec. Yeah, are you able to see it now?
Yes.
Yeah. So when I'm switching my tab, what is happening is the simulation is paused, so you can't actually see anything moving right now. Uh, Let me explain what happens right here. So whenever there is an obstacle over here, within 15 centimeters, what happens is it turns. Oh, sorry, it turns in a clockwise direction. Okay, and once it turns, the distance starts increasing more than 15. So then it moves a bit forward. So it will move in a bit diagonal direction until it again encounters the wall, and it will again turn ultimately until it turns to a 90-degree right angle where it can see a completely straight path. It will keep turning slightly until the straight line is achieved. We can make this more intuitive by adding servo motors. but servo motors don't have enough speed. So they can be used for precision but not speed. So yeah. After this, I'll show you another simulation that I have created. This simulation actually simulates the mechanism wheel movements. So here we have our move forward, move backward, turn left and turn right as usual. But what extra we can do with mechanism wheels is that we can move horizontally left, we can move horizontally right, then we can turn right at the same point. Wait, turn right. Oh, sorry, that right. Yeah. So we can move front right, which is gonna be we'll move diagonally forward in the towards the right side. It's gonna be somewhat like this. And the move left front is gonna be this in the left direction, front diagonal. Similarly, back right and back left is self-explanatory. Uh, what we're going to be doing here, as I explained to you guys in the video which I showed at the beginning, if you I'll share it once again so you guys can see it. So this is going to be our left movement. So when it is moving left, what we want to do is the front right is going to move in the forward direction. Rear right is going to move in the backward direction. Front left is going to move in the backward direction, and the rear left is going to move in the forward direction. So that's what we will just define in these uh, functions. So for move left, motor 1 forward on. So this is going to be our motor 1, which is going forward. Motor 4 backward on, which is going to be our this one, which is going to move in the backward direction. So it will be moving in this towards our left. And similarly, this one, motor 3, this is our motor 3, which will move in the backward direction. And this is motor 2, this will move in the forward direction. So when all 4 of these wheels, the movement adds up together, it will give a combined movement towards the left. Similarly, this move right will give a combined movement towards the right. All right. So let me show you that also. So we can see here yeah. Also, when you're running the simulation, you can pause the simulation so you can see what exactly is happening. This will help you in debugging. So
Hello, Likit.
yeah. Okay.
After completing this session, if you have any other projects in Wokwi,
Yeah.
please share that also.
Yeah, I'll share with you.
Yeah,
Actually,
okay.
I have only variations of what I've done right now. I don't have many projects on Wokwi. But you can get many templates on Wokwi actually. And those are good enough and to learn. For example, I'll show you how to go to that also.
Likit, we
Yeah.
can do that after everything you have already decided. That after that's over, then we'll show how we can get different templates as well.
Yeah, sure. So here, when we are running the program, when you pause the program, what you can see is what actually is happening with the pins. So here, our GPIO 2 is out is high. So what is our GPIO 2 connected to? Our GPIO 2 is connected to motor 1 forward. So we want motor 1 to turn to move forward. So yes, that is out is high. What is GPIO 3? Out is low. GPIO3 is connected to motor 1 backward, which we want to be low. So if there is something wrong in your code, and you're not able to understand, the syntax is proper, but then the output that you're seeing is wrong, you can pause the code, and you can see what is the output given by the pins on the pico. So this is one more useful tip. And when you okay, so let's continue the simulation. So this is all four are moving backward, all four motors moving backward to move the robot in the backward direction. Next, this is to move in the left direction, horizontally left. So forward, and our uh, front, whatever you're moving, right? If you're moving in the left direction, so you need your front left to be in the reverse, front left motor to run in the backward direction, and your opposite front right is going to move in the forward direction. And whatever is your rear motors, they are going to move in the opposite direction of whatever your front motors correspondingly are doing. All right. So for moving right, we can see that our front left is moving in the forward direction, and our front right is moving in the reverse direction. So this will help us move towards the right direction. So one more tip is, if you guys want to turn right, you will have to move your left motors forward. And if you want to turn left, you're going to move your right motors forward. That is what is happening here, but in a more complex mechanism, so that it will move in a horizontal direction. And let me just run the rest simulation. You can see what I had just explained. So now the simulation is completed. I will share whatever is, I'll share my project links to uh, uh, Samir, who will post it on our Excel sheet. What you can actually do is, if you're using someone else's uh, what do you say, like what I have made, if you want to copy it, you can just go click on this downward arrow here, and you can save a copy for yourself. Once you do that, you can find it over here. From your account, you can check your my projects. It will be listed over here. All right. So if I save this one, if I save a copy here, it will ask for a name. So now we can see whatever I had saved, it has come over here. So you can copy mine and use it like that, right? Yeah. So this was all with my. This was everything I needed to tell about the simulation part of things. Uh, so I wanted to show you guys what a breadboard looks like from the inside, actually, so you can get a more clear understanding. Uh, Sivaraman, can you spotlight me after I join from my phone?
Yeah. Okay.
Yeah, let me just join from my phone. Give me a second.
Hello.
Hello.
Okay. Okay. Yes.
Nikit, can you unmute yourself from one of the devices?
Yeah. So is it echoing?
No, no, it's completely fine.
Okay. So as you can see, this is a breadboard. This is the insides of a breadboard. Uh, so let me just focus. Yeah, you can if you can make out over here, you can see that there are two small slots here, which is dividing our front row and our rear row. These two pins are not connected together, whereas all these will be shorted, but whatever is below from here to down, that these two are not shorted together, each other. So you will have to put a pin from here to here, a small jumper if you want, to connect this whole row together. And similarly, when you're looking at the horizontal side, you can see that all the uh, horizontal pins are shorted together. And here I have another setup. Here I am using a Pi Pico W along with something called as a time of flight sensor. You can see the sensor here.
Uh, can you take it some more back? Yeah.
Yeah. So this is the time of flight sensor. What this does is this actually uses a laser, infrared laser. It is a substitute for your ultrasonic sensor. The thing with this time of flight sensor is it is much more precise in its measurements, and also when it comes to ultrasonic sensor, if you are using it to determine the distance of something which is soft, for example, if you're determining the distance of a towel or something like that, what happens is the sound waves which has come out, those will bounce, they won't bounce back. What we need for an ultrasonic sensor to work is for this echo pin, whatever it is, sorry, for the trigger pin, whatever it is giving the uh, signal out, right, our ultrasonic wave, that will be absorbed by the cloth. And this cannot be used in situations, for example, if you are in a acoustic chamber, or if you are in a theater where you need to use a ultrasonic sensor, this you can use this sensor as a substitute for ultrasonic sensors. So I'll just show you a code which will run this thing. I'll just run Thorny code. And Thorny is basically used for running codes on MicroPython. So we'll use that over here. Okay. So this is the code for Thorny. So what happens is, let me just run this. Yeah. So you guys can see it is continuously recording distances. And if I shine it properly, you can see a pink glare on the camera where I'm showing you, right? That is because this is an infrared laser. So we cannot see it with the naked eye, but you can see it through a camera. And the maximum this module can detect is 81 centimeters. You can get other high-end modules. This is VL53L0X. You get one called VL53L1X that has more range, but that also costs higher than this. So this was all I had to say. I hope the session was good and you guys enjoyed it. If I can get some uh, So any reviews on how I did? Anything I need to improve on?
Nikit, can you do one thing? The thing that you are going to show how to get templates for Wokwi directly. That would be helpful for our participants.
Yeah, I'll show. So you go to Wokwi here. You get your latest projects over here. So what you can do is we have gone here, right? Starter templates. We have used our MicroPython template from here. Just scroll down. You can get MicroPython examples. Right now, MicroPython is not used that much like on Wokwi because MicroPython was very recently introduced. Even PyPico is running in its beta version. That's why we don't have a PyPico in MicroPython. So you can try out your projects with non-MicroPython codes. It will be similar to what you guys did on your TinkerCAD. So you'll be using something that's based on C. So you can use any one of these codes, like any one of these projects. What actually Wokwi does is, if you are gonna save a project, right? I'm gonna save this project. I can't save it as unlisted until I don't join a paid plan. Okay, so whatever anybody does on Wokwi, it is open for everybody to view until and unless it is not a paid person. So you get many different kinds of projects, not only for your PyPico, you can even get it for or ESP32. ESP32 has even more projects. Let me show you an example. So see, this code is even using Wi-Fi. So you can understand what an NTP server is, etc. and stuff. If you're not able to understand anything, the best resource I can tell you to go to is YouTube. If not YouTube, if you can't find anything on YouTube, then you can always use ChatGPT to understand anything that you don't know. So this is a normal time clock, which is going to be showing us the Pacific time, UTC. So I can show you other examples also. This is an OLED display. So what I had displayed over here on the terminal, right? If you want to use your ESP32 or your Raspberry Pi Pico, if you're using it on your bot, and if you want to show some output on the bot, which you want to see without using your computer, so you can use this kind of display or a I2C display for that matter. You can find those over here. See, I2C displays or your OLED displays. You can use these to show information when your Pico is not connected to your laptop. Also, one more thing: whenever you save any, as
Likit,
yeah, yeah, tell me.
yeah, okay. Yeah. Do you have any physical build of robot
I have a physical build.
with you?
I have a physical build, but I don't have anybody with me
Okay.
right now to show it.
So,
Actually, I can show it. I'll try to show it with my webcam. I'm
oh,
not sure if the quality will be the best.
yeah, you can
Try
do
to
that.
see it.
Oh, not a show. Just show them your physical one.
Give me 2 minutes. I'll just set it up.
Sivaram, till Likit sets up his robot, can you proceed with the other things, the other important dates?
Yeah, yeah. Uh, so guys, so listen. We have another session on 4th January from 1 p.m. to 3 p.m. where you can show your simulation model that you have built until 4th January. Even if you don't have it, just attend the meet. Uh, you will learn from others who done with the simulation. And one more thing, we will release the form on the deadline day, not before that. So you can time until 5th January to work with your models. So have your time and do your best with that model. Yes, you have lots of time to work with, and you can try new things with that two of the simulation tools.
Amirtha, are you ready with your robot as well?
Yes.
Okay. Likit, can you just stop sharing your screen? It'll pin Amirtha's video. Yeah, I have pinned the video. Can you unmute yourself?
Oh, sorry. Can you see the robot now?
Yeah, it's absolutely visible.
Okay. I have built a gesture control robot. I have made this by ESP32 gesture module, which transmitter and the receiver is the same ESP32. When you on this, one second. Okay. Can I show the demo, or I will first explain then and then I will demo it.
Whichever you are comfortable with.
Okay. First I will show and then I will.
First, you can show the demo and yeah.
We can simply. Okay. Now I can explain it. One second. Sorry for the interruption. I used two motor drivers and four motors, which are 300 RPM, and wheels, which controls these motor drivers control the front two motors, and these back motor driver controls the back side, and this is the ESP32 One second. This is one second. I can't able to show you properly because I made this this design. One second. ESP32 module. This is Wi-Fi module, so that's why we can easily connect these two modules. And this is the brain of the like a CPU of the computer, the processor. Yeah. I, can you hear me? Hello.
Yes, we can hear you. I think your video is paused. Does everyone see that?
I think there might be some internet issues. Uh, Likhit, are you there? Are you? Can you show it in 5 minutes?
Yeah, I'm there. I'm not able to get it to turn on actually, so I can show you the build.
Yeah, you can just show the build and you can just explain it in 2 odd minutes so that people get a glimpse of what they are gonna be doing in Paradox 25.